Yeah, that cleaned up pretty well. So now I can take a measurement of this diameter, and then I'll know I'm looking for a bearing to press onto there, and then I can take a measure of the outside of that bearing and either go by that, or I could take a measurement of the bore. I'll probably take all those measurements to my bearing guy and let him do the dirty work for me. Now I realize this is only for the tensioning arm, but boy, this bearing is so cooked. This is why I get all punch drunk or punch happy when I go to flea markets and stuff like that, because you never know what you might need. Let's see if we can start it with the tip of this one. And it moved. And now this is the smallest straight pin one I've got. Will that fit in there? Nope. Need the neck size down, which I don't have. So I'm going to use this one here. This used to be a really sharp tip on it, like a scribe, and I got stupid with it one day and used it as a punch and broke the very tiny tip off. So now it's back to, you know, that pin was so loose though, it really wasn't bad at all. I could have used a nail. There we go. Ah, that's interesting. It wasn't a pin at all. It's funny, when I cleaned the end of the pin there, it almost looked like I saw a slot for a screwdriver. The reason why is because what I was looking at what I'm looking at are 2 half cylinders. How much you want to bet this was a cotter pin? This was a cotter pin that was in there. Yeah, it's not a hollow pin, so it's not a spring pin. I think it's the 2 halves to a cotter pin that's sheared and the pieces fell away. It's also why it came out so easy. So that is going to be ready to be put back in service as soon as I get everything I need, and you know. So next I'm going to take off these 2 caps. Here's this one here, and there's another one down this end here. And what's on the bottom of this is just a sharp pin. I'm going to show you that. And then that pin is on the other side of this. Basically, it's the tip of this screw. This screw's got a lock nut around it, so it's an adjustment that you're going to make. And I really don't need to take this off, but it's going to be easier for me to clean and keep gunk from getting in here. I'm going to be able to clean up. It's kind of a cup on the other side of this, and I get a feeling that grease is supposed to be packed in it, and it's going to be a lot easier for me to clean that out and then put new grease in. Put this back in when I've got that barber pole shaped deal ready to go, and make my adjustment. So they're coming out. So far all of these screws have been, with just the slightest amount of persuasion, very cooperative. Hey, what's a little screw? Spring, I mean. Oh, we have something interesting. Alright, so there's the little cone-shaped protrusion that rides kind of like almost like a dead center on a lathe would ride on the end of the piece you're turning. Same principle here, and we know that's adjustable through here. But I'll tell you what, there's a little hole. There's a little hole right here, right there. Why do I think this is a cup that somehow What if you're supposed to sit oil up in the top here and let it spill through? That's kind of weird. Wow. The plot thickens. When I took this cap off, this little spring protrudes up, so it's under tension when this cap is screwed down. Pushing down, I take the spring out of its hole. You can see it's a short spring. And then that allows this rod to actually come right out. Now this rod is what the belt shipper actually rides on. But what I don't get is why can't this just be held in there? Why does this have to be under spring tension? In other words, why would this need the ability to go up and down a little bit? Huh? Riddle me that. What the heck did I do? Oh, put them in the parts cleaner. Oh, bummer. I just took this out of the parts washer to bring it over here, and that rides up and down on this. And if for some reason they've got this so it can spring up and down a little bit as it has to, maybe that's just to help in case it binds. I don't know, not quite sure why, but the reason why I said bummer is because I didn't notice when I took this off, but the casting's broken right there. Right there. So this puppy is going to wanna not stay captive on this. To fix that, what's going to happen is either I'm going to have somebody do this for me, or I'm going to have to get talented real fast. And I mean, really, what I'm thinking, how I would handle this is I would build this whole area right here up with maybe silica bronze or something, and then come back and put this in a mill and mill a new groove right through there to accept this. Yeah. So in a perfect world, that's what Steve would do. Well, it's not good news, but I'm still going to forge ahead with this thing. Worst case scenario is I can put this back together and have a drill press that I just can't shift the speeds. Now the reality is I wasn't going to get the proper speeds out of this thing anyways, because I'm not going to be running this from an overhead line shaft. Oh hey, anybody hungry? Cheddar cheese crackers. Yeah, pretty nasty. How much I want to bet a mouse got a hold of these and dragged them in there. Although if a mouse had gotten a hold of them, they probably wouldn't be in there. They'd probably be long eaten and gone. Those are gross. Alright, where was I? Oh, I was saying how the guy who had this when I bought it from him, he explained to me, he says, you know, it runs too fast. Well, sure, it ran too fast because he had a standard 1725 RPM motor. Even with a pulley that big around on the thing, it was spinning way too fast. And the reason why is because this was originally designed to be run from an overhead shaft, a line shaft in a mill. And I think the RPM on those shafts is somewhere like around, they actually had a standard. I actually read it in the old South Bend lathe book, How to Run a Lathe. But I mean, it's really low RPMs, like 250 I want to say, maybe even lower than that. Point is, 250 to 1725, that's a big jump. So yeah, so you're setting this thing for a 1/2 inch drill, or the largest drill that this thing's supposed to handle, and you're going way too fast. So I did see somebody had one of these on eBay, I think they were selling, or somewhere I saw one of these for sale. Actually, it wasn't one of these. It was another brand of old drill. But again, supposed to be run by flat belt line shaft. What he did was he got a gear reduction drive, put it on the back of the thing. So he had his modern electric motor spinning the gear reduction drive, reducing the RPMs for the motor down to something more manageable for the old flat belt drive. Back it up to my problem here. If I can't fix this and I can't shift it, what I'll do is I'll put a belt on here, keep it always in one pulley position, and put a 3-phase motor on here with a variable frequency drive on it, and it'll be more money than I wanted to put into this thing, but I'll have a drill press then that I can have real tight control of the speed. Just a thought. I'm just thinking outside the box here in case, you know, in case I decide to not try and tackle this because of my my limited skills. Alright, so in the meantime, let's put this spring in this doohickey here in the box. And I'm going to pull this cap, and pull this gear out, and go to town.